Hello, this is a quick little demo of what the QQ plot is all about as we check the assumption of normality. We'll have a full check for normality in a different video. You'll see that what we have here is 21 individuals all producing scores. Those scores have a mean of 100. We're comparing with, a mean of 106 being compared with a mu of 100. And we've done all of the calculations to discover a t-sample score of 1.97, possibly significant. We haven't looked up the cutoff point yet, and an effect size of moderate strength at 0.43. So to do the QQ plot, remember Q just stands for quantile, which you can think about in terms of percentile, the percent of scores lower than a given score. And in this case, the quantile is for what we would expect if the distribution was normal. So I'm going to go ahead and do the very first step. You are not asked to do these calculations yourself, but I think it's really helpful for you to see what the calculation means by watching me do it. The formulas are a little complicated. The first thing I'm doing is I'm sorting all these scores according to their rank from smallest to largest. So now we can see here that all these scores are sorted. None of these data changed because none of the information changed. We just sorted them out. And so now we're going to figure out if this distribution was normal, what quantile would it be in, or what percent of scores would be below and above that score. So I've done the calculations already. So we can see the quantile here, and this is important for you to understand what these quantiles are. This is the quantile of what we would predict for a distribution for normal distribution. So it's not the quantile of this score. It's not the quantile of that score. It's the quantile for a normal distribution. If it was normal, what would be the quantile for the very lowest score? And so we can see that for a score of 81, the lowest score, 2% of the scores would be lower. We can see that right in the middle here, this 105 is the score right in the middle, and 50% of the scores are lower. And 98% of the scores, if the distribution was normal, 98% of the scores would be lower than the highest score. So that's what these quantiles mean. They're predicted or expected. Then we figure out the t-score for all of those expected quantiles. And that's just a goofy calculation that you don't need to know, but we figure all of those out. And so we know that a t-score, if this was a normal distribution, the t-score for the lowest score would be minus 1.98. We know the t-score for the score that's right in the middle would be 0, which makes sense because we know the mean of a normal distribution is 0. And the top score would be 1.98. We'd have a perfectly symmetrical distribution. We can see here that we go minus 1.57 and 1.47. 1.18, and at the other end, minus 1.18. So this is a perfectly normal distribution. And then finally, we use a familiar formula. We just take these t-scores in this case, and we figure out what the expected score would be actually for the z-score. And so if we had a distribution with these characteristics that was perfectly normal, the lowest ranked score would be a 78. We actually got an 81. The score right in the middle of the distribution at the 50th percentile would be a 106. We actually got a 105. The score at the very top would be a 134, and we actually got a 130. So what we do then is we're going to plot these scores in what we call a scatter plot, meaning that there will be a y-axis and an x-axis, and every score that is on every score will be partnered. The top score will be partnered with the lower score. Let me get all these data selected here. There we go. So now I've selected our 2 rows of data. I'm going to insert what we call a scatter plot. It's just this dot 1 on the bottom. I'm going to compare the expected scores with the raw scores. Now, as you saw in the illustrations in the lecture, QQ plots are generally square. What we need to do, since it's starting its axes at 0, I'm just going to make a change here and ask it to start at 80 so that we can look at the plot more sensibly. So I'm going to put the lowest score in there, and I'm going to do the same on the y-axis. I'm just going to change these to 80 so that it's a nice square plot. That's how QQ plots generally look. Okay, so we can see a fairly nice straight row of lines. Let's double check it by adding a chart element, a trend line, then we'll get that line that we saw in all those pictures. And this is what we see. So this is our QQ plot. It's based on one axis having the predicted score, the other axis having the actual score. And we can see here that this lowest person had I think I might have cut the lowest person off because this is actually the second lowest person. If we look at our data, I'll show you what I mean. I think I might have cut it out of the chart when I set that lower boundary because we should have an X expected score of 80, and here both these are above 80. So our second person, we would have expected a score of 85. We actually got a score of 84. That's this right here. Here we can see this on the 85, here on the 84. If we go to the highest score, I don't think I cut anything off there, we can see that the predicted score would have been 134. We can see this on the y-axis. The actual score was 130, and that's consistent with what these data are showing, the 130 and the 134. So that's what's being predicted when we use a QQ plot. This one, folks, it really does look pretty decent. Pretty nice along the line. We do have this point up here. This kind of pattern might be consistent with a little bit of skew, a little bit up here too, but let's take a look and see if it's normal enough, which is all we're looking for when we test for normality. And with that said, I'm going to continue this little lecture to show you how to actually look this up in the tool instead of having to do these formulas, which are a little bit complex. So in order to use our tool, we're going to use this QQ plot generator. All you're going to do is load your data. So we're going to go to this paste upload data link at the link that's provided for you. So we'll get to paste and upload data. And I wish I could get rid of this add. I'm not quite seeing where the little X is, but it's in our way. Maybe I can close it. There we go. Let's go back to that paste upload data. So all I'm going to do is paste the data. So what we're pasting is actually our raw data. So we'll grab that raw data, copy it, and then let's put it into this tool. I'm just going to ignore all the stuff that's here and just paste it. And there we go, and we'll push import data. Now we can just scroll down. There's a lot at the bottom of this, but what we really want to do is just generate the QQ plot. It's asking me to select a data column. So let's go ahead and select our column. Column B1 is the only one we have. Now we can generate a QQ plot. And we come down here and we see the plot looking fairly similar to ours. They use a slightly different method. It looks like they are calculating it based on standardized scores, but the idea will be the same. And so we can see, once again, we have a little bit of distortion in the tails, possibly indicating a little bit of skew. I won't go any further into the statistics that we'll see below this because I'll do that in a separate video.